A spacesuit is a tiny spaceship, air, water, power, and protection wrapped around a person. In vacuum, there's no air to breathe, brutal temperature swings, and micrometeoroids moving like bullets. There are two families: IVA suits for launch and emergencies, and EVA suits for spacewalks. IVA suits keep crews alive if a cabin leaks. Lighter, simpler, and tied to the spacecraft for life support. EVA suits, the EMU on the ISS, carry everything on your back so you can work outside for hours. The backpack, called the PLSS, supplies oxygen, removes carbon dioxide, circulates air, and powers cooling. Under the white shell is a liquid cooling and ventilation garment, thin tubes that carry water to whisk heat away. A gas bladder holds pressure, a tough restraint layer sets shape, and an outer shell blocks sunlight and tiny debris. The helmet is clear polycarbonate with a sun visor coated in gold to reflect harsh infrared light. Microphones inside a fabric cap carry every word to mission control and to your partner on the other loop. Gloves are the hardest part, warm, grippy, and articulated, yet they still fatigue hands after hours of gripping tools. Bearings at shoulders, arms, and waist let you bend at low pressure without fighting a stiff balloon. ISS suits run around 4.3 psi of pure oxygen. Astronauts pre-breathe oxygen to purge nitrogen and avoid the bends. Before hatch open. Leak checks, tethers on, fans up, coolant flowing, tools staged, and a final go from the team. Outside, the suit keeps internal pressure steady while venting moisture and waste heat through radiators of water. Power tools and foot restraints turn astronauts into precise mechanics, swapping boxes, routing cables, and freeing stuck bolts. For safety, a tiny jetpack called Safer can fly you back if a tether fails, rare but rehearsed. The outer shell is layered like armor, spreading the shock of tiny impacts into harmless bruises in fabric. There's a water bag and sometimes a snack. Bathroom needs are handled by an absorbent garment inside. CO2 scrubbing used to rely on single-use cartridges. Newer systems regenerate in place by venting captured gas to space. Cooling water dumps heat through the backpack. Without it, you'd overheat fast inside that insulated shell. Airflows sweep the visor to fight fog and to keep oxygen fresh across your face. A typical spacewalk lasts 6 to 7 hours with scheduled pauses to check pressure, power, and CO2. Mobility comes from placement, foot restraints, handrails everywhere, and choreography planned to the minute. On Earth, crews practice underwater in a giant pool. Divers act as safety and gravity helpers. Chambers test suits in vacuum and extreme temperatures. Quiet rehearsals for the noise of a real EVA. Different spacecraft use different IVA suits: Russia's SOCOL, SpaceX's black and white suit, and NASA's new orange OCSS. The next generation, like the Aximu for Artemis, adds hip mobility, improved gloves, and better dust seals for the moon. Lunar dust is sharp and clingy. Seals and filters must survive gritty electrostatic powder everywhere. Helmet lights and visors manage glare and deep shadow. On the moon, sunlight is harsh and shade is jet black. Fabrics blend aramid and glass fibers with coatings that shrug off abrasion and space ultraviolet light. Tiny leaks are rare. If pressure falls, procedures guide a retreat to the airlock or a quick patch and return. Everything is tethered: pens, tools, even checklists, to keep work on track and nothing drifting away. Power comes from rechargeable packs sized to outrun a full EVA plus margin. Medical sensors feed the ground your heart rate and suit status. Controllers can call for rest before you feel it. Even timing is protective. Teams schedule EVAs to avoid predicted scatterings of space debris. From inside the bubble, Earth fills your vision. Work to do, but a view that steals a heartbeat. Communication and cadence matter. Clear calls and deliberate motions keep partners synchronized. Back inside, suits vent down, helmets come off, and the first breath of cabin air feels warm and heavy. Crews and tech service suits like aircraft, drying cooling loops, swapping filters, and fixing scuffed parts. Future suits aim for lighter joints, smarter gloves, and modular parts you can repair far from Earth. Walking on Mars will demand efficient legs, dust-hardy zippers, and backpacks that sip power for long treks. Remember the recipe: pressure to breathe, cooling to shed heat, scrubbers to clean air, and armor against space. A spacesuit is engineering made intimate, life support you can wear, proven one careful step at a time. With better suits, we can build, explore, and stay, on the station, the moon, and beyond. Like, comment, and subscribe for more videos like this.